So this part here, this is called the revolving nose piece. It's able to turn, you're able to turn it. And on the revolving nose piece, you've got the different types of objectives. And in my case, I've got 5 different objectives. The magnification of each objective is written directly on the objective, and it's also color-coded. So over here we've got the 4 times objective, 10 times magnification, 20 times magnification, 40 times magnification, and also 100 times magnification. And the magnification of the objective has to be multiplied with the magnification of the eyepiece to give the total magnification of the microscope currently in use. You also notice that with 100 times objective, in my case, we've got oil written on here. And this indicates that it's an oil immersion objective, and it has to be used in conjunction with immersion oil, which I'm going to explain in a different episode. So you also see that over here each objective has a rubber grip, and the reason is that it's easier for the objective to be unscrewed and unmounted. You should always make sure that it's completely turned in, and generally you should not really unmount the objective unless there's a good reason, because every time when you remove the objective there's the danger of dust being introduced into the optical system. Another thing that I would like to indicate here is the following. You see the front part is able to retract here. This objective is spring-loaded, and this means that if somebody makes a mistake and actually rotates the stage too far upwards, and if there's contact with the objective, so that the objective doesn't break and the specimen does not break, the front part of the objective will retract. Notice I'm not really touching the front lens part, but only here at the side, so that should be okay. But generally it's also not something that you normally want to touch. So again, the revolving nose piece over here with, in my case, 4 different objectives. And you notice, of course, that the objectives are all arranged in an ascending order, because as you switch magnification, of course, you want to turn over from objective to objective and not want to skip a few of those. So it's important that they are arranged in ascending order. Over here, towards the right side of the microscope, we have at the very top the main switch. Over here, the light intensity regulator, a dimmer. And down here we have the 2 focus knobs. The coarse focus knob raises and lowers the stage very quickly, and the fine focus knob. I'm going to talk about those 2 later. But first of all, I want to lose a couple of words and talk about switching the microscope on and off. When you switch the microscope on, always make sure that you first turn the dimmer all the way down to a low light intensity. Then you turn on the main switch, and you're going to see over here that the light still does not burn yet. And then you slowly start to turn up the light intensity. And when you switch the microscope off, you reduce the light intensity first, and then you switch off the main switch. Why is it important to follow this sequence? If you turn up the light intensity first, and then you turn on the main switch like this, then the light will start to come on very quickly, and this will heat up the light very quickly. And when you turn it off immediately, then it will basically turn off the light bulb very quickly, and this very quick change in temperature reduces the lifespan of the light bulb. So it's always much better to first lower the light intensity and then you switch it off. Okay. Down here we have the coarse focus adjustment knob, which raises and lowers the stage very quickly, and the fine focus adjustment knob, which also raises and lowers the stage, but however in very, very small steps, and you're not able to visually see that. It's very important that you do never use the coarse focus knob with a high power objective in place. The reason is, obviously, is because there's the danger of actually crashing the objective into the specimen. But there's no danger of actually doing that when you use the low power objective. So you first focus using the coarse knob, and then you rotate to higher power, and then you only use the fine focus adjustment knob. And this way you're going to be safe. So let's turn on the microscope a little bit. I'm going to raise the stage. Again, turn it all the way down, switch it on, slowly turn up the light intensity, and you're going to see down here in the illumination system, the light beam, and my microscope over here has a so-called Köhler illumination. And this illumination system includes a diaphragm also over the light source. And by turning the ring over here, you're actually opening and closing the diaphragm. And this way you're able to adjust the width of the light beam. Why is this important? This way you're actually only illuminating the part of the specimen that you're actually looking at. So otherwise, if you open it all the way, there's a lot of stray light, which decreases the image quality, decreases contrast, and if you take photographs with a microscope, the picture is going to look a little bit washed out. So you probably want to adjust it in such a way that you're only illuminating the part that you're really looking at. So this was one diaphragm, and now we're going to have a look at the second diaphragm, which is located beneath the stage, which is the condenser aperture diaphragm. So down here beneath the stage we have another optical system. This is the so-called condenser, and integrated into the condenser we have the so-called condenser aperture diaphragm, which can be controlled using this horizontal lever over here. And the condenser aperture diaphragm is important for regulating contrast and resolution. And normally what you should do is the following. You should adjust the value of the setting of the aperture diaphragm according to the value of the corresponding objective. Each objective has a certain aperture value written on it, and this value is the value with optimum resolution, and it should also be set here. But usually people are not just going to leave it on one place, but you're actually going to work with it by moving it left and right, and this way you can adjust both contrast and also resolution. And what I'm going to do now is the following. We're going to have a look at this condenser aperture diaphragm, but first of all I have to remove the condenser a little bit. So I'm going to raise the stage. Over here on the side I'm going to turn this knob, and I'm going to lower the whole condenser system. It should normally always be towards the top. Over here I've got a little screw. I'm going to loosen the screw, and I can now slide it down, and I see I'm a little bit too low, so I can move it up again, and I can remove the whole condenser system with the filter holder. Okay, so we're going to have a look at this right now. So here in front of us now is the whole condenser system with our aperture diaphragm. On the side here, left and right, you see two screws, and these are the so-called centering screws, and you're able to center the condenser in such a way that the light beam is centered by turning these screws. Usually you only have to do this adjustment once. And now let's have a look at the diaphragm. I'm going to turn around the condenser all the way to the top. And over here you can see it looks a little bit bluish. The reason is there is an integrated blue filter. And if I move the horizontal lever left and right, you can see the diaphragm opening and closing. And what I'm going to do now is the following. I'm going to remove the filter holder. Got to be a little bit careful because there's a blue filter included. I'm going to remove the filter holder. Here is the blue filter. Got to be careful with that. Here we see a lens, an optical system. Okay, you can see this a little bit where if I hold my finger behind it, you should be able to see that it actually, there's a lens here. There's another lens over here, and over here you can again see the diaphragm. Now, why is there a blue filter included? The reason is that the microscope light has a somewhat reddish tint, especially as the lamp gets older, it becomes more and more red. So this blue filter compensates this color drift a little bit. Alternatively, in conjunction with a blue filter, you can also put a so-called dark field patch stop into here, and this filter will now invert not invert, but essentially it will be like this, that the main objects will appear bright on a dark background. So it's not a completely negative image, but it's an optical contrasting method which is sometimes very useful for observing very fine details under the microscope. So essentially the point I'm showing you this is that this is also the place where you can put several filters in, So I'm going to put the whole thing together again. I'm going to put, in this case I'm going to put the patch stop in. I'm going to carefully put the filter holder onto the condenser, and then I'm going to install the whole thing again in the microscope.